Let's take a look at a second example. So for this problem, we have x cubed is equal to y to the fifth. To find the first derivative, start with the derivative of x cubed, which is 3x squared. Set that equal to the derivative of y to the fifth, which is 5y to the fourth dy dx. And now to solve for dy dx, I only have one step. Get rid of the 5y to the fourth. So when I divide both sides by 5y to the fourth, I'm going to end up getting dy dx is equal to 3x squared over 5y to the fourth. And this is what we're going to use for our first derivative. Now to find the second derivative, I need to use the quotient rule. So, second derivative notation, d squared y dx squared is equal to low, 5y to the fourth, d high, 6x, minus high, 3x squared, d low, 20y cubed, dy dx, all over low squared. Remember to square the entire denominator. I recommend just writing it in parentheses with a squared and then simplifying it on the next step. All right, if I clean up what I have a little bit for starters, my second derivative so far is 30x y to the fourth minus 60x squared y cubed dy dx all over, now if I do 5 squared I get 25, and if I do y to the fourth squared I get y to the eighth. And it's going to look like there are lots of things that you can simplify at this point. For example, 30, 60, and 25 are all divisible by 5. But before I simplify anything, I need to get rid of this dy dx. That needs to be your next step. So the dy dx is going to get replaced with 3x squared over 5y to the fourth. So that's going to give us this. 30x y to the fourth minus 60x squared y cubed times 3x squared over 5y to the fourth, all divided by 25y to the eighth. So now I'm going to simplify that second term in the numerator a little bit. I'm going to keep my 30x y to the fourth. And now let's start with the numbers. 60 times 3 is 180. 180 divided by 5 is 36. X squared times x squared is going to give me x to the fourth. Y cubed divided by y to the fourth gives me all over y, or y to the negative 1. That is all still being divided by 25y to the eighth. So now I have a fraction and a fraction again. So to clear out the fraction, I multiply by the denominator up top. And that's going to give me 30x y to the fifth minus 36 x to the fourth all over 25y to the ninth. So now I have all x's and y's. Now I need to see if there's anything I can do to substitute and simplify further. So we're going to go back and look at what our original function was. In this case, we had x cubed is equal to y to the fifth. And here's what I notice. Here's a y to the fifth. I'm going to replace it with an x cubed and see where that gets me. So now my second derivative is equal to 30x times x cubed minus 36x to the fourth all over 25y to the ninth. Well, that first term is really just 30x to the fourth. So if I have 30x to the fourth minus 36x to the fourth, I have negative 6x to the fourth over 25y to the ninth, which looks pretty simplified. However, the bottom has y to the ninth, and I know y to the fifth is equal to x cubed. So what I'm going to do is split this apart a little bit further. Negative 6x to the fourth over 25, this is y to the fifth times y to the fourth to get to y to the ninth. And now I can substitute again and get rid of this y to the fifth. So now I'm going to have negative 6x to the fourth over 25 x to the third y to the fourth, and now I can reduce the x's. So I can cross off the exponent 4 up top and get rid of the x cubed on the bottom completely, and my final answer will be negative 6x over 25y to the fourth. And that is the second derivative of the function x cubed equals y to the fifth.